Many discussions about artificial intelligence treat it as a thinking mind. That single mistake changes how we understand its power and, more importantly, how we miscalculate its risks. So let's start by correcting that one core misconception. The difference between a mind and a tool is everything. We tend to imagine AI with these very human qualities, things like consciousness or common sense. But where a human understands something, a modern AI is really just performing a calculation. For example, it doesn't actually know a photo shows a cat. What it's doing is identifying a statistical pattern in the pixels that matches millions of other images that humans have labeled cat. It's incredibly sophisticated pattern matching, not genuine understanding. In fact, every single AI we interact with today, from the assistant on your phone to the programs that can beat the world's best chess players, is what's called narrow AI. These are powerful tools, for sure, but each one is built for one and only one specific job. Now, this is where a lot of the confusion comes in, because narrow AI often gets mixed up with the science fiction idea of artificial general intelligence, or AGI. That's the hypothetical machine that could learn or reason about any task a human can. It's a fascinating idea, but right now, it's purely theoretical. So the distinction is clear. What we have today is a tool, not a mind. And that raises a really important question. How does this tool actually learn to do its job? Well, the engine that drives most of this technology is a process called machine learning. And it's less about teaching in the human sense and more about statistical discovery. At its core, it's a three-step process. First, the system ingests just an enormous amount of data. We're talking millions of texts, images, or songs. Second, it sifts through all that data to identify statistical patterns. And finally, it uses those patterns to make a prediction when it sees new data for the first time. A music recommendation system is the perfect example. It doesn't understand your taste. It just analyzes millions of user histories and finds a pattern. It sees that people who listened to song A and song B also tended to listen to song C. Your listening history is just one more pattern to be matched. This whole pattern matching approach is incredibly effective, but its greatest strength is also its greatest weakness. The system is completely dependent on the data it's trained on, which leads to a serious problem. What happens if that data is flawed? That complete dependency on historical data is where some of the technology's most serious and unintended consequences begin to surface. This leads directly to something called algorithmic bias. If you train an AI on data that reflects our own historical human biases in things like hiring or loan applications, the AI doesn't just learn those biases, it learns to replicate them, and it often amplifies them at an incredible scale. And these aren't just theoretical risks. There have been documented, real-world consequences. In a well-known case from 2015, an image recognition system made a deeply offensive error because of underrepresentation in its training data. In another case, a risk assessment tool used in the U.S. court system was found to be twice as likely to incorrectly flag Black defendants as future risks than white defendants. Now, here's the crucial part to understand. The algorithm isn't being malicious. It has no concept of fairness at all. It is simply doing its job perfectly, which is to find and apply the patterns it was given, flaws and all. And when you look beyond bias in a single system, scaling this technology up introduces even broader societal risks. Things like the rapid spread of misinformation, the potential for large-scale job displacement, and serious concerns about autonomous weapons. These longer-term risks have prompted stark warnings from some of the world's most prominent scientists. The fear isn't about an AI that suddenly turns evil, like in the movies. It's about a superintelligence that pursues its programmed goals so relentlessly that it causes catastrophic harm, simply because its goals aren't aligned with human values or even our survival. All of these challenges have sparked a global conversation, and it really centers on one urgent question. How do we make sure this powerful technology develops safely and ethically? And we're starting to see responses emerge on multiple fronts. Governments around the world are drafting new regulations. Entire research institutes are now dedicated to AI safety. And world leaders are gathering at global summits to try and establish some ground rules for responsible development. When you boil it all down, AI is a mirror. It reflects the data we feed it, the human biases hidden in that data, and the goals we task it with. So the most important question isn't about what the technology will become. It's about who gets to decide what goals we give it in the first place.